All right, I had to redo the slides here real quick here in regards to the lecture here. So we got ourselves, let's see where we left off. We left off with something like this. The slide may look a little bit different than what you've seen on the previous video, but we did graph the line y equals 2. We graphed the vertical line x equals -3. And so there's that. Let's keep on going. So we should be able to finish up 2.3 today. So let's go with it. I think we are on, let's see, C, D, and E. All right, can you graph for me this equation right here? And so notice it's not in slope-intercept form. So all we do is we just move it to become slope-intercept form. So we move this around like this. And now we are ready to graph. This should be equal signs right here. All right, and yes, you are right. The only thing is we have to change the slope into a fraction. And so we're going to put a little extra little divided by 1 here. And all yours. Give you guys a little bit of head start here. Finish it up, and then I will as well. All right, we start off at 3. 1, 2, 3. And now we're going to go down 2, right 1. So down 2, 1 to the right, and we go right there. Yep. Cool, there it is. Okay, so there's your graphing linear equations. So now let's move on to finding the slope. All right, again, something you are probably familiar with from Algebra 1, also geometry. I'm sure you guys did quite a bit of this stuff in geometry. Did you guys do a lot of this stuff in geometry? Okay. So let's say I have a point called, I'm going to call it 2, 3. I have another point, 2, 3, 4, 5, and I'm going to call it 3, 4, 5. I'm going to just call it 5, 7 right here. Don't have to be very specific as long as I know the coordinates are. Can you give me the slope of this line? So from geometry, you guys know this is the geometry definition of slope. It's rise over run. So it depends how much you go up, and then depends how much you go sideways to get to the next dot here. So in this case, notice if we go from 2 up to 5, we're going to have to go up 3 units to get there. All right, and if we go from the, oh, sorry, real quick here. The Y marker, we're going to have to go up 4. There you go. Thank you. 4 units to get as high, because this tells the 3 and the 7 tells you how much elevation you have. It's the difference in the Y values. And then what you do is you go across. And the question is, how far do you go across to get to here? Well, then that means you have to go from 2 to 5, and that would be a value of 3. In this case, it'll be adding 4 from the 2 to get to 7. 4 from the 3 to get to 7, sorry. Adding 3 from the 2 to get to 5. Okay, so I'm going to do it, let you see guys a different way here. So isn't 4 really the difference between, because we started at 3, we went by 4 to get to 7. So isn't 4 really just this? Isn't just the subtraction of 7 minus 3? The high value, or the difference between the y values, 7 and 3. What's the difference between my x values? 5 and 2. So let's come up with a formula. Let's say this. Let's say that this equation, or this point, is just like a generic point anywhere in space called x1, y1. This guy is any point out in space called x2, y2. And those little 2's represent it's the second point. The little 1's represent it's just my first point. So let's do this here. Can you get this 7? This 7 belongs to what arbitrary point? It's this one. So this is y2 minus, according to the formula. And what does y3 correspond to? Or sorry, 3 correspond to? Y1. Perfect. Okay, so then 5 is x2 minus x1, and there is our formula. Our formula for slope is we figure out the changes in our y values, and we figure out the changes in our x values. Okay, let's go for it. You know, I should say this. This was just an explanation. It wasn't really example 2 or exercise 2. Exercise 3 is find the slope of these guys. That's when we're going to actually work. All right, I'm going to put them on the list here, and then I'll let you guys do it. And then a little bit more complicated. Actually, no, let's do one at a time. Good. All yours there. If you can go ahead of me, that's fine. Go for it. All right, so slope would be, that's going to be, we can label these here, right? My first point, x coordinate, my y of my first coordinate, my x value or the coordinate, my second point, and the y coordinate of my second point. So let's go -12, subtract 5. Now what I like to do, I like to put in these little parentheses. Kind of helps me a bit here. So then I know exactly what I plugged in. That was my y2. That was my y1. What's my x2? What's my x1? Perfect. Okay, so in this case, what I could do is I could change this into addition. And that would give me, looks like -17 over -4. And if you see two negatives in fractions here, they will cancel each other out. So this slope is 17 over 4. And of course, I got to give you fractions here. So all yours there. Give you guys a little bit of time to try this one here. Can you find me the slope of a line that passes those 2 points? Give you guys 30-second head start. Go. All right, it almost helps to do these separate from each other. So let me start over here. So I'm going to go plug in my points here. Dun, dun, my little parentheses. I'm going to go -1/7, subtract 1/3. Then it's 2/5, subtract 1/2. So it does almost help to just to do the top all by itself all the way till you're done, and then do the bottom until you're done. So normally what we do is want to change everything into addition because it's easier to work with negatives and then addition as opposed to like negatives and then subtraction as well. So I need a common denominator of 21 here. 21. So on top of the first fraction, I should get a -3. On top of the second fraction, I should get a -7 and keep on going until we have, looks like -10 over 21. Okay, let's do the denominator here. Common denominators of 5 and 2 would make 10. And then it'll be 2 times 5 to make a 10. So 2 times 2 is a 4. And make a 5 times 5, 5 times 2 to make 10. Therefore, 1 times, oh, you know what? I forgot to change this to addition. It doesn't matter really, but maybe this will be just easier to work with here. So -5. So I got myself a -1 over 10. Oh, yes, that's true. Look at this. Those negatives will cancel each other out because they're fractions. One's on top, one's on the bottom. And how do we get rid of a complex fraction? On top, the top value stays the same. And what happens is instead of having a divide symbol, what we do is we have a multiplication symbol. And because of that, what we have to do is we have to take the reciprocal of our bottom number. And if we do that, we get 100 on top, 21 on the bottom. It looks kind of funny, but it is true. That slope is 100 over 21. Okay, one more thing to sort of put together here. So notice the slope formula. We can say this here. If I can spell point correctly here. the point slope form. How do we get the point slope form? So here it is. If you're talking about it's the slope formula, comes from the slope formula. This is kind of cool how mathematics works. Like you see this slope formula a whole bunch, you used it, you've thought through it, and then all of a sudden this kind of like new idea pops up. Like, hey, what if I do this? And here's what we do. We think of the slope formula as just the measurement of the steepness of a line connecting 2 points together, right? That one and that one. And those are individual points, right? Those could be like 5, 7, 12, and 8. And so the genius of a person that saw this was to say, look, if that is true, what I can do is I could just make this point right here just be arbitrary. I can make it anywhere I like. So I can make this just into variables, and I can place this point anywhere I like, because no matter where I have this point, so let me do this real quickly again. Let's say the point is down here all of a sudden, right? Notice whenever I put a secondary point, I can always establish a line that goes through both of these, right? No matter where I go. So we're just going to change let me do that again. Sorry, because I want to get the formula just right for you guys here. So instead of changing that one, what we do is we do this here. Let's say this was like 2, 3. And let's say this was 5, 7, right? So we can get a slope of those two, right? And that's the formula. That's the way we use the formula. So along the way, I think it was still Descartes. He figured out, you know what? What happens if I just do this? What happens if I just, instead of a predefined point over here, I make y2 and x2 just be arbitrary variables. I can move this point anywhere I like now. Move it here, I can move it here. And the thing that we discovered is no matter where you move it, you always have a line that can connect those two pieces together. So if you have a line, that means you can get an equation of that line. So here's what we do. It's a modified. We take this and say, you know what? y2 is just going to be a variable for us. x2 is just going to be a variable for us. And then if I multiply both sides by this, because I want to get rid of some fractions here. Those will go away. And I'm left with x minus x1 times m, y minus y1. And then I don't like the way it looks right like this right here. So in fact, I don't like even the m being on this side. I want the m on this side. So I have this. Let's swap sides here real quick. Y minus y1, m x minus x1. So how does that help us? It helps us to get equations of lines or description of lines. So let's go with it. We have 1, 2 problems left and some other stuff. So this is exercise number 4. It says find the equation of a line that has the given points and slope. So here it is. I look on a graph. I pretend I look in a graph. And I notice this line is a slope of 2. I also know it goes through 3, 4. So the question is, can I get a slope of this line? I think I can from the point slope form. Look at this. This is cool. As long as I have a point, and then as long as I have a slope, I can use this form right here. So it's going to be y minus, and then we're bringing in the y1 right here. It just doesn't matter what point it is, as long as it's a point on the line. Slope, it comes in as 2. And there's my 3 that comes in. That's so cool. Check this out. I'm pretty much done. I'm going to distribute this out to 2x minus 6, looks like. I add 4 to both sides. And I got myself an equation of a line right there. Perfecto. Okay, that's the easy one. That's one type of problem like this. Okay, if we go to B, so how about this? What happens if I am just given 2 points? That's it, not a slope. I just know that this line goes through -4, 1. Put a dot there, graph it if you want, and 6, 8. Can I get an equation of this line? Absolutely. Let's follow the form here. Oh, hold on. Hold on. The form says I need a point and I need a slope. I have 2 points. That's what I have. I have 2 points, but no slope. Yes. The question is, can you get still? If you have 2 points, can you get the slope? Absolutely. So let's do our slope formula first. We'll get our slope that we want, and then we'll plug it back in. So it's kind of like, hey, you don't know have something? Let's go get that something. Let's plug it back in. So y2 minus y1, x2 minus x1. So on top, that was an easy one. Hold on. Didn't even need to do that one, right? Because sometimes you don't need to do 8 minus 4 is just 4. This is plus plus, and that gets me a 7. 4/7 is my slope. Okay, now I get to plug in this guy. Now, which point do I plug in? -1, 4, or 6, 8? So these points right here is not the fact that it has to point to here. It's the fact that it has to be a slope and it has to be a point. So you could actually use 6, 8 if you like. But what we're going to do here is I'm going to use this one just to show you guys something. So it's y minus 4. Everybody good there? The slope comes in from over here, 4/7. Then it becomes, ooh, careful here. Look at this. This is x subtract. But then when you plug it in, you're plugging in a -1. So what's subtract -1 going to do? Add 1. You just put in its opposite. That's it. That's cool. Okay, almost done. Let's go for it here. So we got ourselves distributing the 4/7 to the x, distributing the 4/7 to the 1. Then we are going to add 4 to both sides. Okay, a little bit of work here. Let's see. Oh, yes, the easy way. The easy way is just do this. This is a whole number. This is a fraction. And you could just write it as 4 big units with 4/7 remaining. Okay, if you need to get common denominators, you would have to do this. Place a 1 underneath here. Make all of them the same denominator now, which is 7 and 7. The first fraction is going to stay the same. The second fraction needs a little multiplier of 7 on both top and bottom. And if you add those guys together, you should get 32/7. So this is just perfectly fine. This is just perfectly fine. Both of those are totally correct answers, and everything works. Okay, so now let's go on to one more piece here that we got to do. So when we think about lines, now instead of just one line, now we have 2 lines. And whenever we have 2 lines on the same axes, we have these 2 special lines that are connected to each other. One is called a parallel line. Parallel line means you have lines going the same exact direction. Sometimes we label them as L1, L2, or capital 1, L, capital L2. What we notice about these graphs is this real quick here. That means the slope of line 1 and the slope of line 2 are exactly the same, right? Otherwise, they would be crossing each other. We also should note this here, the fact that the slopes intercepts cannot be the same because they have to be two different lines. If the slope is the same and the y-intercept is the same, then we have ourselves the same line. Okay, then we have a perpendicular lines. Again, the special way two lines cross each other. This is like intersections right here. This is the way normal intersections work in America and across the world right there. And right there, what they do is they intersect at exactly a 90-degree angle. And the slopes are interesting. The slopes are, this is the relationship between these two slopes. So M1, slope 1 times slope 2 would get you a -1. So if you multiply these guys' slopes together, the numbers would cancel themselves out and you'd have a negative. An English way of saying it is the slopes are opposite, reciprocal of each other. Opposite, reciprocal. Okay, let's do a problem like that. So exercise 5, find the equation of a line that passes through 2, -1 and is perpendicular to this equation right here. Oh, okay. Now, let's see if I trained you well. All right. Let's see if I trained you well. Whenever you say find the equation of a line, automatically, what should you be thinking in your head? Yes, I trained you well. You should be automatically thinking this right here. So whatever I need to do to get to that right there. Oh, you know what? I even know some stuff. Look at this. Don't I have a point already? Yeah. In fact, let's plug in the point real quick here. So this is y minus, y1 is -1. Therefore, we just switch that. Notice this is the m that we need. We don't know our m yet. I have my points in there. That's cool. The m I need to somehow get from this guy. And the m that I want is perpendicular to that right there. Okay, so let's go for it. So to find out even what the slope of this line is, I'm going to subtract 2x from both sides. I'm going to divide through by -3. And I like to divide each of the pieces by -3. Just kind of makes it a little easier here. Y is equal to, negatives are canceled. So I got myself 2/3 x. And this is going to be just a, whoa. I'll leave it like that. You know, I actually don't even need this, right? Because what am I interested in from this line? I'm only interested in the slope of this line. That's it. So that's what I'm interested in. So the slope here is 2/3. But what I want is, I want the perpendicular slope for my equation. So what's the m value that I want? I want the opposite. So this is positive. We will go negative. And reciprocal, this is 2/3. We want 3/2. So the opposite reciprocal of positive 2/3 is -3/2. Done. This is cool. I plug in my -3/2. And the rest of it is all for you. Go ahead, finish it off. I distribute the -2/3 to x. Negative times the negative is a positive. And 3/2 times 2, the 2's will cancel, just left with 3. And I'm going to subtract 1 from both sides to solve for y. And voila, I get myself the answer. There it is. There's my equation. That goes through to -1. It is perpendicular to that equation. All right, hopefully that was good enough to get us done with 1.3.